Hey students, welcome to the another lecture of chapter number 2 solutions. And till now, as you know, we have covered with the first colligative property, that is relative lowering of vapor pressure. So today we will start with the second topic of colligative properties, that is elevation of boiling point. But I suggest you, if you have not watched the earlier videos of vapor pressure, go and watch those videos first and then you come back to this video for proper understanding of the topic. Okay, and yes, don't forget to like, subscribe to the channel. Okay, आइए तो शुरू करते हैं. The second colligative property, that is elevation of boiling point. Now students, as you all know, what do you mean by a colligative property? So colligative property is such a property of a solution which will depend upon the number of solute particles present in the solution. Correct? So elevation of boiling point is a colligative property. Now before we understand elevation of boiling point, let me first tell you what is boiling point. Correct? So boiling point. Students, boiling point is nothing but the temperature at which a liquid boils. Right? Students, that is the temperature at which a liquid boils. Now, we say that the boiling point of water is 100 degrees Celsius. Right? It means, suppose you take water, right, at 25 degrees Celsius, right? Now slowly I will be increasing the temperature of water. So what will happen? The water will start gaining heat, right? And also it will form vapors. That is the process of evaporation which takes place. But boiling will not occur here. Okay, boiling will only occur when the temperature of water reaches 100 degrees Celsius. So now the question arises that what exactly happens at 100 degrees Celsius that water starts boiling, right? There should be something happening at 100 degrees Celsius which is not occurring at all other temperatures, right? Because of which the water only boils at 100 degrees Celsius. So students, what basically happens is, as I increase my temperature from 25 degrees Celsius to 30, 40, 50, 70, 90 and finally 100. So at 100 degrees Celsius, we find that the vapor pressure will be equal to the atmospheric pressure. Correct? So at 100 degrees Celsius, the vapor pressure of water will be equal to the atmospheric pressure, and this is the reason that water begins to boil. Correct? So now, as a generalized statement, I can tell you that when a liquid boils, the liquid will boil when its vapor pressure becomes equal to the atmospheric pressure. And the temperature at which the vapor pressure of the liquid becomes equal to atmospheric pressure, we call that temperature the boiling point of that liquid. Hence, I can define boiling point as the temperature at which the vapor pressure of liquid equals atmospheric pressure. Correct, students? What is boiling point? It is the temperature at which the vapor pressure of the liquid will equal to the atmospheric pressure. Now, when this particular thing happens, the liquid will begin to boil, and this temperature is known as the boiling point of a liquid. Correct? The boiling point of any liquid, students, is a characteristic of that particular liquid. What I mean to say is, if the boiling point of water is 100 degrees Celsius, then any other liquid, any other pure liquid will not have a boiling point of 100 degrees Celsius. Correct? So boiling point is the characteristic of a liquid. Now, let us understand, as we know, when we talk about atmospheric pressure, now see students, atmospheric pressure can be taken as 1 atmosphere or it can be taken as 1 bar. Correct? We know these two are not exactly the same, right? We know the relation 1 atmosphere is equal to 1.013 bar. Correct? 1 atmosphere, students, is never equal to 1 bar. So if I consider my atmospheric pressure as 1 atmosphere, then the boiling point is known as the normal boiling point of the liquid. And if I consider my atmospheric pressure as 1 bar, then the boiling point of the liquid is known as standard boiling point of the liquid. Correct? So depending on whether your atmospheric pressure is 1 atmosphere or 1 bar, we have normal boiling point and standard boiling point of the liquid, right? Now for our purpose of discussion, see students, we will consider standard boiling point and normal boiling point approximately same. They are roughly the same. कोई बहुत ज़्यादा फर्क नहीं होता है उसके अंदर. They are roughly the same. So in our topic of discussion, we will not use the word normal boiling point or standard boiling point. We will just say boiling point. Okay. Now students, let us understand what do we mean by elevation of boiling point. So for this, consider that I have a solvent. Let me take the example of water. So I have water and water is my solvent. Now I add some sugar to it. Correct? What I am doing is I am adding sugar to it. So this is aqueous solution of sugar. Correct? I am adding some sugar to it and I am making a solution out of it. Now students, as all of you know that vapor pressure of solvent is always more than the vapor pressure of solution. Correct? This we have done in our earlier videos, right? That the vapor pressure of solvent is more than the vapor pressure of solution. And I have told you to remember this line as the golden line of the chapter. Now, so of course, both of them are at same temperature. Suppose both of them are at 25 degrees Celsius or suppose both of them are at room temperature. So, the vapor pressure of water will of course be more than the vapor pressure of the sugar solution, because what happens in sugar solution, there is force of attraction between the sugar and the water molecules. Because of this force of attraction, water cannot move freely from the liquid state to the gas state, and as a result the vapor pressure in the case of solution decreases. Now suppose right now I will just draw one axis, to ease your understanding. So suppose at 25 degrees Celsius, the vapor pressure of water is suppose 0.2. This is in terms of atmosphere. Okay. So at 25 degrees Celsius, the vapor pressure of aqueous solution of sugar, say for example students, it is 0.1, again in terms of atmosphere. Right. Now, when I go on heating it, you know that when you heat it, the vapor pressure increases. Right. So what will happen? The vapor pressure will rise. It will rise, and at one particular temperature it will reach 1 atmosphere, which is my atmospheric pressure. Correct? So at this particular vapor pressure of water, means when it equals atmospheric pressure, the water will begin to boil. Right? And we all know that the temperature, corresponding temperature here will be 100 degrees Celsius. Right? Now here in this case, again, if I go on heating the aqueous solution of sugar, what will happen? The vapor pressure will increase and a time will come when it will reach 1 atmosphere. Right? But since the vapor pressure here is less as compared to that in the solvent, what will happen? See students, it will trap more heat. It will reach to 1 atmosphere, but that will be done by taking more and more heat. And as a result, what will happen? The boiling point that we get here will be more than 100 degrees Celsius. Correct? The boiling point that we get here will be more than 100 degrees Celsius. Now, the question is, what amount of increase in the boiling point is seen? whether it is 100.1 degrees Celsius, 100.2 degrees Celsius, 100.5 degrees Celsius, or 100.7 degrees Celsius. Now that depends, students, on the amount of solute that I have added here, right? Because more the amount of solute I add, more will be the lowering of vapor pressure, and hence more will be the boiling point. Are you understanding? What I am saying is that more the solute I add, when I add more solute, what will happen? Lowering of vapor pressure will be more. Correct? If I add more solute, the lowering of vapor pressure will be more. If the lowering of vapor pressure will be more, then students, it will need more heat to reach to 1 atmospheric pressure. So basically what will happen, that boiling point also increases, right? So the more solute I add, more will be the lowering of vapor pressure and more will be the rise in boiling point. This phenomena of increase in boiling point, students, is what we call elevation of boiling point. And that is our today's topic, right? So whenever you add a non-volatile solute to a volatile solvent, the vapor pressure of the solution decreases. Vapor pressure will decrease, and as a result what will happen? The boiling point of the solution is more than that of the pure solvent. This phenomena is known as elevation of boiling point. I will speak the definition once more, students. You can note it down. When a solution is prepared by adding non-volatile solute to a volatile solvent, the vapor pressure of the solution decreases. Due to this, the boiling point of the solution is always more than the boiling point of the solvent, and this phenomena is known as elevation of boiling point. So students, how can I denote elevation of boiling point? Say for example, TB is my boiling point of solution, correct? And TB0 is my boiling point of pure solvent, correct? So if I subtract these two, when I subtract these two, I get what? My elevation of boiling point, correct? So elevation of boiling point is nothing but the difference between the boiling point of the solution and the boiling point of the solvent, because the boiling point of the solution will always be more than the boiling point of the solvent. Now students, let us understand the elevation of boiling point concept by means of a graph. So I will explain you in graphical form. Suppose students, if I plot a graph of temperature in Kelvin on x-axis, and suppose I take vapor pressure on y-axis, and this line, it corresponds to atmospheric pressure, that is 1 atmosphere, correct? And suppose if I draw the graph, okay, so students, if I plot the graph of vapor pressure versus temperature, then this will be the graph of my solvent and this will be the graph of solution, right? So you can very clearly make out from here that when the vapor pressure of solvent reaches 1 atmosphere, at that time just extrapolate on x-axis and you find out that the boiling point will be, say for example, TB0, right? But because the vapor pressure of solution will be less than that of the solvent, solution will take more heat to reach to the atmospheric pressure of 1 atmosphere. So when the vapor pressure of solution reaches 1 atmosphere, at that time, of course, the boiling point will increase, and suppose that boiling point is TB, right? And as we have seen just now, the delta TB, that is elevation of boiling point, is equal to TB minus TB0, right? It is TB minus TB0, that is the boiling point of your solution minus the boiling point of the solvent. So this difference, my dear students, this difference is your elevation of boiling point. Okay, just think like this. Suppose I have two solutions. Here I have taken the example of one solution, but my dear students, suppose there are two solutions, right? And the two solutions which I have, suppose I have solution 1 and suppose I have solution 2, right? And solution 1 is less concentrated than solution 2. I mean solution 2 is more concentrated. Now you tell me where the graph of solution 1 and 2 will lie. Suppose, just take an example. Suppose this is the graph of solution 1. Students, just think and tell me where the graph of solution 2 should lie, right? And what should be the shape. Now, students, the graph of solution 2, because solution 2 is more concentrated, the graph of solution 2 will appear somewhat like this. It will be parallel. It will be parallel to the graph of solution 1, and the graph of solution 2 will lie like this, and will of course have, if I extrapolate it on the x-axis, you can see that the graph will have higher boiling point than that of solution 1. What is the reason? The reason is that solution 2 is more concentrated than solution 1. As a result, the vapor pressure of solution 2 will be even less than that of the solution 1. So it will need more heat, right, to reach to the atmospheric pressure of 1 atmosphere. And as a result, the boiling point of solution 2 will be more than that of solution 1. See, it's very simple, right? So by this whole graphical thing, students, one thing is very clear, and that is that more the concentration of the solution, right, more will be the lowering of vapor pressure and higher will be the boiling point. Such properties which depend upon concentration of the solutions are colligative properties, and hence the elevation of boiling point is a colligative property. Correct? Now students, let us understand the mathematical form of elevation of boiling point. See students, what actually happens is, we know that since elevation of boiling point is a colligative property, I can write that elevation of boiling point, my dear students, delta TB is the symbol of elevation of boiling point, will be proportional to concentration of the solution, right? Because colligative property का मतलब ही वो होता है कि the properties which depend upon the concentration of solution and nothing else, right? So here there are so many concentration terms. So here the concentration term that I will use is molality. Molality. Now students, why we are not using molarity or normality, and why we are using molality? Because molality is always independent of temperature. Molality will never depend upon temperature, right? So as a result, because we are talking about elevation of boiling point, there is change of temperature, so we are using such a unit which will not depend upon temperature, right? So we are using molality here. Now to remove the proportionality sign, I will need a constant. So as a constant, I take KB. I take KB as my constant, correct? Here student, delta TB is elevation of boiling point. Students, keep this thing in mind. Whenever you are writing the answers in exam, right, you have to mention the meaning of whatever symbols you are using. Okay, M is the molality of the solution, and KB is known as molal elevation constant, or students, it is also known as ebullioscopic constant. Correct? This KB is known as molar elevation constant and ebullioscopic constant, right? Before we proceed further, I would like to tell you one thing about KB, and that students, this KB, correct? This KB, it only depends upon the solvent used. KB is a function of solvent. It only depends upon solvent, right? Now see, this thing may not be given in your NCERT textbook, but if you see the old NEET papers, you will see that in 2015 or 16, this question was asked. That one question was given to you, and they asked in that this value of Kb depends upon what? And 4 different options were given: concentration, temperature, solvent. Students, it will only depend upon solvent and nothing else, right? Kb it only depends upon solvent. Now, what is Kb actually? How can we define Kb? So let's understand, students. If molality is equal to 1, if I take 1 molar solution, then you can see from the equation what will happen. Delta Tb will become equal to Kb, right? If I take the molality of solution as 1, then delta Tb becomes equal to Kb. So now, what is Kb? Students, Kb is defined as the elevation of boiling point of 1 molar solution is called molar elevation constant or ebullioscopic constant Kb. Correct, students? So what I do is, if I take 1 here, delta Tb equals to Kb. So I can define as the elevation of boiling point of 1 molar solution is known as what? Molar elevation constant or ebullioscopic constant. I hope the things are very clear. Yes? Now, sir, what should be the unit of Kb? See, students, unit you can make it out on your own, right? If you make out the unit, what will be the unit? We can write that Kb is equal to delta Tb upon m. Correct? From here we can write Kb is equal to delta Tb by m. So students, the unit will be delta Tb का unit क्या होगा? डिग्री सेल्सियस अगर हम ले, correct? डिग्री सेल्सियस. And students, what is the unit of molality? The unit of molality will be mole per kg. Correct? So now this kg will go here. So what you get? Degree Celsius kg per mole. Correct? But if I want to use SI units, if I want the SI unit of kb, then what I'll do? In place of Celsius, I will take Kelvin, because Kelvin is the SI unit of temperature, kg is the SI unit of mass, and mole is the SI unit of quantity of matter. So the SI unit will become Kelvin kg per mole. Right? See students, it's very easy to understand, and this is all about kb. Now, if I extend this equation, right? If I write delta Tb is equal to kb, students, what is the formula for molality? You all know. It is the weight of solute, it is the weight of solute multiplied by 1000 upon molecular weight of solute into the weight of solvent. Correct? Now, what is W2? आपको मैंने आगे कितनी बार बताया है कि whenever I use 1, it is for the solvent, and whenever I use 2, it is for the solute. Correct? So this is for solute and W1 is for solvent. So if I make Kb the subject, students, if I make Kb the subjects, what I get? I get W1 into M2 into delta Tb, correct? This will go into multiplication divided by W2 into 1000. This is my equation for Kb. Correct? This is my equation for Kb. Symbols have the usual meaning. W1, 1 is for solvent and 2 is for solute. So weight of solvent multiplied by M2, M is the molecular mass, so molecular mass of solute, into elevation of boiling point upon W2, that is the weight of solute, multiplied by 1000. Correct? So this is my equation for Kb. The importance of this equation is we can find out the molecular mass of unknown solute which is present in my dilute solution. Yes, just like Raoult's law, this equation can only be used for dilute solutions, right? So Kb will depend upon solvent, so that I can know from the reference books, or it might be given to you in the question. W1, that is the weight of solvent, that will be given. right? Elevation of boiling point, that we can find out practically. W2 is the weight of solute. We know how much solute we have added. 1000 is constant. So if we know all the parameters, then we can find out M2, that is the molecular mass of the solute from this equation, right? So this is just the application of colligative properties. That colligative property, no matter which colligative property will always be helpful in finding out the molecular weight of unknown solute which is present in the given solution. Now students, the elevation of boiling point has relationship with the enthalpy of vaporization. Okay, so let's study the relationship between elevation of boiling point, that is delta TB, and enthalpy of vaporization. Now students, the relation goes somewhat like this. Your Kb is equal to R T0 square upon 1000 into LV. Correct? This is the relation where Kb, as you know, is your ebullioscopic constant. R is gas constant. Correct? T0 is the boiling point of solvent. 1000 is constant, and LV is latent heat of vaporization of solvent. Correct? In, अब स्टूडेंट्स कौन सी यूनिट दे सकते हैं आपको? दे कैन यूज जूल और कैलोरी पर ग्राम. करेक्ट? योर LV, माइंड दिस इज वेरी इंपॉर्टेंट. Your unit is very important. LV is your latent heat of vaporization of the solvent. Now this latent heat of vaporization of the solvent can be given to you in joule or calorie per gram. Correct? So accordingly, students, see, if it is given in joule, then R you have to use in joule. You know the value, that is 8.314 joule upon Kelvin mole. Correct? And if it is given in calories, you know you have to use 2 calorie per Kelvin mole. Correct? Then you have to use 2 calorie per Kelvin mole. Okay, so this is how you have to select which value of R you have to use depending upon the unit of LV given. Now students, sometimes what may happen, they may give you this latent heat, they may give you in joule or calorie per mole. In place of gram, there may be mole. So now in that case, the modified equation becomes Kb equal to M1 RT0 square upon 1000 into delta H vaporization, where M1 is molecular mass of solvent and delta H vaporization is enthalpy of vaporization. Now the enthalpy of vaporization which is given to you will have the unit of joule or calorie per mole. So now if you are given the enthalpy of vaporization or latent heat of vaporization, if you are given in per gram, in the unit of per gram of solvent, then you have to use the first formula, and if it is given to you in the form of per mole of solvent, then you have to use this formula. Correct? Now if you don't want to remember both the formulas, students, you can just remember this one formula. You can just remember this one formula, and suppose if you are given in joule or calorie per gram, you can convert it into per mole, right? You know how to convert gram to mole. Okay, so you can make calculations. Or the second option is you remember both the formulas. If it is given to you in joule or calorie per gram, then use first formula, and if it is given to you in the form of joule or calorie per mole, then use the second formula. Okay, now students, time for some applications of the concept. So see, we know that food cooks faster in pressure cooker, right? स्टूडेंट्स, आप सबने घर में प्रेशर कुकर यूज किया होगा या देखा होगा प्रेशर कुकर यूज होते हुए. तो थिंक व्हाई वी प्रिफर प्रेशर कुकर इन प्लेस ऑफ ओपन वेसल्स. Because food will cook faster in pressure cooker. Why? The question is why? Right? I won't be explaining you the reason of this question because I want you to think about it. I'll just give you a small hint. This is pressure cooker, right students? And what we are doing, suppose we are boiling potatoes, right? I have kept some potatoes in the pressure cooker. So see what will happen. Of course, because of the formation of steam from water, here the atmospheric pressure in a pressure cooker, students, will be more than 1 atmosphere, correct? 1 atmosphere ज़्यादा ही होगा atmospheric pressure. Now, because of this, you think for yourself why food will cook faster in pressure cooker. Okay? Now see students, this thing is not given in your NCERT textbook. Then why I am discussing it? I am discussing it because this is very, very important for your competitive exams. Right? This question has been asked in your Gujket. And it is also important for your JEE and NEET. Right? So think about it. Why food cooks faster in pressure cooker? One more application I would like to discuss with you. Water boils at lower temperature at high altitudes, right? If you might have gone to some hill station, right, or any such mountain area, then you might have seen that the boiling point of water, which is 100 degrees Celsius at the sea level, it will decrease, right? The water may boil at a lower temperature. Now what is the reason? Again, I want you to think about it. I will just give you a hint. What happens that suppose this is some mountainous area and we have gone there. So as you move to the higher altitude, students, what will happen? Atmospheric pressure decreases, correct? What happens? Your atmospheric pressure decreases, and because of this decrease in the atmospheric pressure, you think what will happen, right? You think what will happen? So now I leave the exact reasons of these two applications up to you to think, right? So please see the video, like the video, and subscribe to my channel if you have not subscribed yet. And yes, do comment the answers in the comment box. Okay, think over it. The application is just elevation of boiling point. It's very easy. Okay, so students, that's all for the topic. Okay, study nicely. Okay, all the best.